Hello ladies and gentlemen. What I'm going to be talking to you about today is how to balance chemical equations. So what you should have already learned how to do is how to write chemical equations given a word equation. What I'm going to show you how to do today is again how to balance chemical equations. So the reason why we have to balance chemical equations is because of this law. It's called the law of conservation of mass. And what it says is in a chemical reaction, matter can't be created or destroyed, which makes sense. You know, it's like I can't just do a reaction and make matter disappear, as far as like just make it turn into nothing. What happens is atoms get rearranged. For instance, something that maybe commonly you might think of where you think matter gets destroyed is, say, like a campfire. You start with this big log of wood, you light it on fire, and then after an hour or two, the log is gone. Well, the matter didn't disappear, it just got rearranged. It changed from a log, something that's heavy and you can see, to something you can't see, which is a gas. So it didn't disappear, it just got rearranged. So matter can't be created or destroyed. Also, law of conservation of mass is that atoms aren't going to change their identity. They're not going to change from carbon into something else, into like hydrogen. The only time that happened is in nuclear decay. So that won't happen in these types of equations. So what we are going to basically be trying to do when we balance an equation is get the same number of atoms of each type on both sides of the equation. So let's kind of review some symbols. So really the only symbols you guys have been using so far for writing chemical equations has been a plus sign and then this arrow. So you should know what those are. The plus sign separates products and reactants from reactants and products from products. But then the arrow represents the product side and the reactant side. It separates them. So typically things on the left side of the arrow are called your reactants. The things on the right side of the arrow are called your products. And then those plus signs separate those more than one reactant or product. Well, these are some symbols that you will probably see. I don't require that you write them, but don't be confused by them or intimidated. All that these mean are the state in which that substance is in. So you'll probably see something like this G. Well, that means gas. So you might see it behind like O2. That's because O2 at room temperature is a gas. You might see it like L when it's around something like, say like water, H2O. They might put L behind it. They also might put G behind water because there is water vapor. Things can exist as a solid, a liquid, or a gas. Here is solid, so you might see something like gold. It would be listed as AU with this symbol behind it, meaning gold solid. Then this is called aqueous. This means that you've got something that's dissolved in water. So you know, for something like, let's say sodium chloride, NaCl, I could write it as either NaCl solid, but then if I took that solid and I dissolved it in water, I would actually write that as NaCl, aqueous now, because it's no longer in a solid state, it's actually dissolved in water. Those aren't things that you necessarily need to know, like you won't have to include this stuff, but it's helpful to know when you're seeing equations because you will probably see these written in some of your equations, but it's not necessary in order to balance them. So you should have already been able to write chemical equations. So basically what you did is you took a word equation like this. So solid iron reacts with oxygen gas to form iron 3 oxide, and you'd write the chemical equation and you get something like this. We call this a skeletal equation. It's not really vital that you know that, but this equation as written actually violates the law of conservation of mass. So the law of conservation of mass says that atoms can't be created or destroyed. Well, based on how this equation is written, on this left side, it's saying that I have one iron atom and 2 oxygen atoms, and it's going to form 2 iron atoms and 3 oxygen atoms. Well, I can't do that. I can't start with 1 iron and then all of a sudden have 2. I can't start with 2 oxygens and then all of a sudden have 3. Basically, I've created an iron and an oxygen atom. Well, I can't do that. That's why we have to balance them, which means we actually are going to need more iron atoms if we wanted to get 2 irons. We're going to need more oxygens, so we add things called coefficients in front of them in order to balance those equations. So what we would actually end up doing to balance this equation is we would add these numbers. So this 4, this 3, and this 2 are called coefficients. What they are is they represent the number of each type. What this means is I would need 4 iron atoms I would need 3 oxygen molecules. When those react, it would produce 2 molecules of Fe2O3. Okay? That's what this balanced equation says. It's the number of molecules that react. So what I'm going to do for you real quick is I'm going to show you how to balance a few chemical reactions. I'm going to put the screen up, and then I'll balance them on the board. So if you just kind of wait a second for me to do that. So here's the 2 reactions that we're going to balance. The first one is this. So what this is, lithium reacts with water to produce hydrogen gas and lithium hydroxide. So what I'm going to do here is I need to balance this reaction. In order to do this, I need to keep track of how many atoms I have on each side. So I'm just going to go through and keep track of those, and I'm going to keep track of them right under the arrow. So I've got lithium, I've got hydrogen, and I've got oxygen. And then I'm just going to keep track of how many I have. I have 1 lithium on this side, I've got 1 lithium on this side. I have 2 hydrogens on this side. I've got 3 hydrogens on this side. I have 1 oxygen on this side, and I have 1 oxygen on this side. So everything in this equation is balanced except for my hydrogens. I need to get more hydrogens over here. So in order to do that, I have to add coefficients. Now, something that a lot of students want to try to do is they want to try to like change subscripts. In other words, they might go, oh, I've got a 2 here, why don't I just change this to a 3? Can't do that, because water is not H3O, it's H2O. I can't change the molecule. The only thing I can do is I can add a number in front of the molecule. So if I wanted to increase my number of hydrogens, I would have to add a number in front of my H2O, meaning I would need more molecules of it. So I'm just going to go ahead and add a 2 there. Okay, so you might say, well, Mr. Cunningham, that's going to give you 4 hydrogens now. And how I do that is I determine my number of hydrogens when I have a coefficient by doing 2 times 2. So it's 2 times the subscript now. So I'd have 4 hydrogens, but that also changed my number of oxygens. I now have 2 times 1 oxygen, which is 2. You might say, well, Mr. Cunningham, before you did this, you were only off on 1 atom, now you're off on 2. And that's true, but that's what I have to do in order to balance this. So now I'm going to come over here on this side, because this side is short atoms. So notice how I'm short 1 hydrogen and 1 oxygen. Well, I could add hydrogens or get more hydrogens by putting something here. But if I put a 2 here, that would give me 5 hydrogens, and then I'd be in the same position that I was before. So I'm not going to add a number there. What I'm going to actually do is add a number here. Because if I put a 2 here, notice how that's going to change my number of lithiums, my number of oxygens, and my number of hydrogens all by 1. So I'm basically gaining 1 more lithium, oxygen, and hydrogen. So now I'm going to have 2 lithiums. I'm going to have 2 hydrogens here plus these 2, because 2 times 1 is 2. So I'm going to have 4 hydrogens here. And now I'm going to have 2 oxygens here. Now I need to come back over to this left side, because my lithiums are now short by 1. And I need to increase my number of lithiums by 1. Well, in order to do that, I'm going to put a 2 right here, and that will change these lithiums to 2. My equation is now balanced. I have the same number of each type of atom on both sides. Now on your test, what I'll ask you to do is, you don't want to leave this blank. What you'll actually do is put a 1 right here. So that balances my equation. Okay? Let's do another one. This one we're going to look at is this. So, in order to balance this equation, what I want you to notice is that we have, first of all, we have calciums in it. So I've got some calcium, I've got some chlorine, I've got some silver. whenever you see a polyatomic ion, you need to, what I want you to do is I want you to treat it as a unit. Now the only time you wouldn't do this is if, notice how this right here is nitrate. If you see a polyatomic ion on one side of the equation, and you also see it on the other side of the equation, I want you to keep track of it as a unit. In other words, I'm going to write down here NO3 instead of keeping the atoms separate, because if you try and keep track of your nitrogens and your oxygens, and things just get really confusing. So you're going to use NO3 and keep that as like one unit, like how many NO3s do I have, not how many nitrogens and how many oxygens. So I'm going to keep track of all my atoms right now. So I've got calcium over here, and there's only one. And I've got one calcium over here. I've got a 2 behind this Cl for chlorine, so I've got 2 chlorines on the left. I have 1 on the right. I have 1 silver on the left. I have 1 on the right. Then for my nitrates, this nitrate itself is NO3, which means I have 1 NO3 right there. But then on this side, notice how I have a 2 behind my NO3. That means I have 2 nitrates, okay? So I've got 2 of those. So here's where I'm having an issue. My chlorines are too high on the left side, and my nitrates are too high on the right side. So I need to increase my number of nitrates on the left, and I need to increase my chlorides on the right. So I'm going to start with the nitrates. In order to get my number of nitrates to go up by 1, I need to bring in another AgNO3 molecule. So I'm going to put a 2 here. Okay, so that 2 now does 2 things. It changes my number of silvers. I now have 2 silvers. And I now also have 2 nitrates. But now I need to come back over here, because by changing those numbers, now my chlorines and my silvers are short. Well, what's nice is, if I put a 2 here, that's going to give me 2 silvers, and it's going to give me 2 chlorines, which fixes my problem. And now my equation is balanced. So, hopefully this video was helpful on how to balance equations. If you have any questions, make sure you let me know. I'd be happy to answer any of this for you. Thanks for watching.